Section 2.6, proving statements about segments and angles. I'd like you to start with this warm-up to take a look at some of the properties you've been working on to see if you can identify which property and how to use it. So I'd like you to pause the video and try these 4 questions, restart the video, and then see how you're doing on these properties and understanding them. So if you did these correctly, take a look and see if you got them correct. The first one, you should have filled in the measure of angle 1, because really what you're doing is you're just flip-flopping around the equal sign, which is the symmetric property. In the second example, what you're really doing is you're really using the transitive property, because we're saying if AB is equal to CD and then CD is equal to TU, then AB would be equal to TU. That is the transitive property. The third one gets a little tricky sometimes, because what you have then is you're actually taking this original amount right here and you are adding an equal amount AB. And you're taking the original amount WX and you're adding to it AB. And so that is adding equals. So that's the addition property of equality. And then the last one, you're really just using substitution with the angle addition postulate. You're substituting what the measure of angle EFG is equal to, that 28 degrees, into that blank. So hopefully that gives you some feedback on how you're doing on that, but please ask questions as needed. So we are going to start working on 2-column proofs in this lesson. So we're going to start here, and we're going to actually kind of eliminate this explanation, because you'll see in a few minutes that our 2-column proof really just has a statement and a reason. Our explanation could be more of a verbal thing or just kind of what we're doing, but we really don't absolutely need that. So we are given that AB right here is equal to CD. And what we are being asked to prove is we are being asked to prove that the whole segment AC then is equal to the whole segment BD. And this is called overlapping segments. So let's start out with our first statement of AB is equal to CD. And we were given that statement. Okay, it was listed for us. So then what we can do is we can use segment addition postulate to say that AB plus BC is equal to the whole segment AC, and that is our segment addition postulate. And then we can do the same thing for BD. We can say that BD is equal to CD plus BC, and that again is segment addition postulate. So now here's where we can use some substitution. Because AB is equal to CD, we can take what AB is equal to right here, this CD, and we can substitute it in for AB. So then that would give us, for this statement, we would put the CD in for AB, and we would have CD plus BC equals AC. And again, that was substitution. And now we have an example again of the transitive property. We have if BD right here is equal to CD plus BC, and CD plus BC is equal to AC, then what we have is then that BD is equal to AC, and that is the transitive property, like a logic chain. Has to be in order. And last but not least, this is what we're trying to prove right here. We're not quite there, but if we just flip those around, we could say then that AC is equal to BD by the symmetric property. So these are the things you're going to need to start doing, is you're going to need to be able to justify your reasoning and what you're doing. So, all right, we did this in a different video. We're going to give it another try. There's multiple ways of doing this proof, so I'm going to do it a little bit differently this time. Again, I'm going to go ahead and call this given statement, just for simplicity, that angle 1 is congruent to angle 3, because that's just going to help us with not having so many letters that we have to keep track of. So that's what we've been given here, is that these angles are congruent. Okay, so we just did overlapping segments, so maybe this will be helpful now that we're doing these overlapping angles again. So what we are supposed to try to prove is that angle EBA is congruent to angle DBC. And we can approach the proof similarly. It just gets a little trickier sometimes with the way this is worded with the angles. So we're going to start with our given statement. Usually that comes first, or one of the given statements. Sometimes you'll have multiple. But we're going to start with that angle 1 is congruent to angle 3, and that is given. And then we are going to say that the measure of angle 1 is equal to the measure of angle 3. And again, that's such a picky difference, but that's really our definition of congruent segments. When our segments are congruent, definition of congruent segments. That's not segments, we just did overlapping segments. Definition of congruent angles. If the angles are congruent, then their measures are the same. So now this step is a little interesting, but what we can actually say here is we can take that original statement, the measure of angle 1 equals, and we can have the measure of angle 3, but what we could do is we could add an equal amount. And angle 2 right here is an equal amount, okay? It's not the same as 1 and 3 necessarily, but we could say that the measure of angle 1 plus the measure of angle 2 would equal the measure of angle 3 plus the measure of angle 2, because we're just adding an equal angle to each one. And so again, that's our addition property of equality, and we don't have to write all that out, but just so we once in a while do, I think it's helpful. So now we also know that the measure of angle EBA is equal to the measure of angle 1 plus the measure of angle 2 because of angle addition. And likewise, we know that the measure of angle DBC is equal to the measure of angle 2 plus 3. And again, that's angle addition postulate. So now, again, using substitution, we could, since 1 and 3 are the same, we could substitute in 1 for 3. So I'll go here and highlight, since we know that the measure of angle 1 is equal to the measure of angle 3, we could put in here, for this 1, we could put the 3. So we could say that the measure of angle, I don't really want to use that color, hold on. So we could say then that the measure of angle EBA is equal to the measure of angle 3 plus the measure of angle 2. And then look at these right here. Look at this and this. They're the same. The measure of angle 2 plus measure of angle 3 is the same as the measure of angle 3 and 2. So that means then that these two would also be congruent to each other and equal to each other, those angles. So now we can actually go back and say that the measure of angle EBA then is equal to the measure of angle DBC, because we're going to put what that is equal to in. We can substitute what is equal to. And so this is our substitution, and we have proved what we set out to do. So I'm trying to do proofs with you so that you kind of get the hang of it. But this is kind of our beginning of two-column proofs. So a proof is a logical argument that shows a statement is true. A two-column proof is just one type of proof that has numbered statements and corresponding reasons. So we have statements, we've been working on that. And then we have reasons, and we put them in a logical order. and we number them. So each one will have a corresponding number. A theorem is a statement that has already been proven to be true as a result of other true statements. And then they can be used as other reasons in proofs. So then you can actually use that. So, two-column proofs, what we can use for those justifications or our reason column is give any given information, like congruence of angles or things that are marked congruent, definitions like midpoint, perpendicular lines, etc., postulates, and like segment addition postulate, and any facts that you establish in your proof already previously to that. So, yes, in a previous lesson, we worked on the reflexive, symmetric, and transitive, and those were all based on equality. So our previous theorems were equality theorems, but these are congruence theorems, but they work very similarly. So these are going to be congruence, okay, and that's the only thing that's going to be different. So again, previously for the reflexive property, we would have, or for the symmetric property, let's go down to this one, we would have said something like, if AB equals CD, then CD is equal to AB. So we just flipped it around the equal sign. Okay, so that's what it looked like previous to this. But now what we're going to be working on is showing congruence instead. So for example, for the reflexive property, we would say that segment, so we have that physical line over it, segment AB is congruent to segment AB. It is itself, okay? It's like a mirror image, remember? The symmetric property, again, would say if, now we're, instead of using this AB over here that we had, that was the length of the segment, the distance between the points. Now we're saying if the physical segment AB is congruent to the physical segment that we can identify CD, then by the symmetric property, we can say that CD then is congruent to AB. So again, that's flipped around the equal sign. And then last but not least, the transitive property would say if segment AB is congruent to segment CD, and if segment CD is congruent to segment, let's say EF, then we know that the segment AB would also be congruent to the segment EF. And again, it's the same thing for angles, okay? We already did this with angles. Now we're just doing it with, or we already did it with equality. Now we're doing it with, again, congruence here. So again, we could say that angle A is congruent to angle A. And for the symmetric property, we could say, again, that we actually probably should, since we're talking about congruence, those are the angles being the same measure, we should use that the measure of angle A is equal to the measure of angle A. And if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle C. Oh, sorry. I got ahead of myself for the transitive measure of angle A. So again, flips it across the equal sign. And again, a picky detail between equality and the measure being congruent. And these are all like congruent instead of the equal. So that's the difference. That's why I put that measure in there. And then last but not least, if the measure of actually, we won't really need these measures because we are using congruence, but we'll just go ahead. The measure of angle A then is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C. Then the measure of angle A is equal to the measure of angle C. So that's kind of previous what we did and kind of connecting to what we're doing now. So we're going to use those properties again and try to keep them straight, the differences. So we're going to prove if M is the midpoint of, now we're going to work on a 2-column proof, okay? You can see the statements and reasons, and we're going to start small by, I'm going to give you the statements and you're just going to have to fill in the reasons. And the more times you do this and try to process through reading the statements and reasons together, the better you'll become at doing proofs. So what we have in this first statement is if M is the midpoint of segment AB, so here's M, and here's AB. It says if M is the midpoint of AB, then we want to prove that AB is 2 times AM. So M is the midpoint of AB, that is given. AM is congruent to MB. That is by definition of midpoint. So these are congruent. So because the segments are physically congruent, that means their measures are the same. So that's where this is so picky between going from here, the segments being congruent and the lengths being the same, the distance between the points. But if you can, try to put both in. And since they're already listed here, we can again practice these different reasons and justifications. So this is the definition of congruence. So now I'm saying that AM plus MB is equal to AB. So what I am showing here is segment addition postulate, because I'm saying that AM right here, oops, got one ahead of myself, AM plus MB right here is equal to the whole thing AB. So that is segment addition postulate. And then we have AM plus AM is equal to AB. Well, what we did here, since AM right here and MB are the same, we can substitute what MB is equal to. We can substitute what MB is equal to in, okay? So we can put the AM in there. Since MB and MB are the same, we can put AM in there, which gives us step 5, and that would be substitution. And here's where the explanation column kind of comes in handy, because you could actually describe that you substituted AM in for MB. And then now when we just look at AM right here plus AM, that is 2AM. If you think of this as, you know, X plus X, it's 2X. It's kind of the same thing. And so what we say for that is we're really just using algebra properties to simplify. Okay, let's try another one. This one's a lot simpler. Let's see how you can do on this one. I'd like you to pause the video, read through the statements and the reasons and the proof, and see if you can get them correct. And then you can start the video again and to see if you got it right. So what we have here is we have a pretty simple proof, and a lot of times it is helpful to draw the picture that we have AB, so from A to B is 5, and from B to C is 6, and we're supposed to prove that AC then right here is 11. Well, it's pretty obvious, okay? So we started with the statements that are given, okay? So here's our given if, so that is our reason. And then the next step said AC equals AB plus BC. Well, that is segment addition postulate. And so now I see that the next step, AC equals 5 plus 6. So again, they're taking what AB is equal to, which was the 5, and putting it in here. And they're doing the same with BC right here, and they're substituting what BC is equal to in. So that is substitution. And then lastly, we just added the 5 and 6 together. So again, that's kind of simplify using algebra. All right, so we have one more, okay? I'll kind of go through this one together. Again, try to see if you may want to try these proofs on your own a second time and just watch the video to see if you're getting it correct a second time. The more times you repeat and do the same proof over and over, the better you will get at doing these proofs. All right. B is the midpoint of AC and C is the midpoint of BD. Prove that AB is equal to CD. So the first statement says B is the midpoint of AC. So B is the midpoint, so that means these two segments are congruent. And the reason is because that was given. Okay, but it also said that C is the midpoint of BD. So that makes this segment right here congruent to this segment right here. And again, that was given. So now our next statement said that, I've already marked this, but it said that AB is equal to BC, and that is definition of midpoint. And the next step says that BC is equal to CD, and again, that's definition of midpoint. And so now the next step, if you notice, this is set up really nice. We have AB is congruent to BC, and then we have BC is congruent to CD. So that means that AB is congruent to CD by the transitive property. So now the segments are congruent, so their lengths are the same. So we have proven then that AB is equal to CD. And to go again from this step to this step is a minor picky detail, but that is really our definition of congruence. All right, so give these a try. Again, might want to try them multiple times, but this is the end of our 2.6.